Hello students, welcome back to your favorite and India's most affordable learning platform, Physics Wallah. So we have started the new chapter in the last session. So that is the laws of motion, which is very important chapter. So in the last session of laws of motion, we have covered just the basics, right? So what are the different types of forces, and then how do we represent those forces on in the form of free body diagram. So that's very important. And then we have seen what is Newton's first law of motion, and then so equilibrium condition questions we have solved, right? So in continuation of the laws of motion, in lecture 2 we are going to discuss today the Newton's second law of motion, and again which will be linked with the first law of motion, like we have to use the same conditions of first law of motion, and then we have to do second law of motion. So these are our two targets today. Okay, so as usual, for the next 1 hour, just be with me, avoid all the disturbances around you guys, and at the end of the lecture it's a very important to write your own short notes. And if any student is not writing the short notes, at least start writing from now. So from the units and measurement chapter onwards, you just complete the short notes of each chapter. Once you complete the chapter, what you do is just prepare the complete summary of that chapter in just 4 to 5 pages. That's it. Okay, so that's very important, guys. Clear? Chalo. So let's begin the today's session. So first, that is Newton's second law of motion. So what's the Newton's second law of motion says? So the rate of change of momentum of a body is directly proportional to the external force applied on the body, and change takes place in the direction of the applied force. So the rate of change of momentum. So in the grade 9th level, you studied what is momentum, right? So the momentum is denoted by P. Yes or no? So the rate of change of momentum. So the rate of change in physics we call the rate of change, means rate means per time. So the very small change in momentum with respect to time, so it is directly proportional to the external force. So it's directly proportional to the external force. So this is a Newton's second law. So from here I can write, so take out the proportional symbol and put the proportional constant as k. So that k is equals to here considered as 1. Okay, that constant. So now see, you already know the momentum in the grade 9th level itself. So the momentum which is denoted by P. Yes or no? So whose formula is given as mass into velocity. So can you write the dimensions of momentum, guys? You already know. So what are the dimensional formula? So the dimensions of this one. So mass means m. So velocity L t to the power minus 1. Yes, clear? Yes or no? So the velocity is distance by time, right? So here mass is m and L t to the power minus 1. That's a momentum. So here the same thing I am substituting. So just observe carefully. So let me do it in the next slide. So just take this as a just statement. So now in the next slide, let me write F is equals to, we have got dp by dt. So the rate of change in momentum is directly proportional to the force applied, right? So from here I am writing F is equals to d. So in place of momentum, shall I write mv by dt? So now here I can write, so you know the UV method, right? So in the basic maths we have studied, so the UV method, which is called the product rule. So there what we do, so let's take m constant and differentiate the v, and then let's take v constant, then differentiate mass. So m into dv by dt plus v into dm by dt. So this is the actual formula of your Newton's second law of motion. So this is the Newton's second law of motion. This is the actual formula, 100% correct. So but in general, so what we take is, so generally the mass is considered as constant. So generally, so the mass of any body is considered as constant. Mass is said to be constant. Okay. So if the mass is constant, so then shall I say the differentiation of the mass with respect to time, it's going to be 0. Yes or no? So the differentiation of the mass with respect to time, it's going to be 0. So then the Newton's second law changes this way. So the F is equals to m into dv by dt plus v into dm by dt. So if the mass is constant, so this term will become 0. So this whole term, the second term, whole thing will become 0. So in such case, so the force will be equals to m into simply dv by dt. F is equals to m into dv by dt, and we know that, so the F is equals to m into what is dv by dt. So differentiation of velocity with respect to time, so which is nothing but the acceleration, which is nothing but simply the acceleration. So this formula is valid when the body's mass is not changing with respect to time. If the body's mass is not changing with respect to time, in such cases only the force is F is equals to ma is the Newton's second law. Otherwise, so the actual formula for the Newton's second law is this one. Okay, so like 95% of the times we use this formula only, unless and until they mention in the question that the mass is varying with respect to time, so we can use this formula. If the mass is varying, then we should use this formula. Okay, especially in the rocket propulsion questions, where we'll discuss in the fourth lecture or fifth lecture, we'll discuss about the rocket propulsion. So in the rocket propulsion questions, the rocket's mass changes as it moves up. Why? So the fuel consumes, right? So the fuel will be consumed, right? So as the fuel consumes, its mass decreases. So in such case, you can't use this formula. So you have to use this whole formula. Understanding? So there I'll discuss in detail. So as of now, you just have the derivation or the formula of the Newton's second law of motion and have the understanding. So when to use this and when to use this. Clear? Sure. So let's move further. So let's take the simple application based questions. So pause the video and try it on your own, guys. A player takes 0.1 seconds in catching a ball of mass 150 grams. So moving with a velocity 20 meter per second. So then the force imparted by the ball on the hand of the player. So we have to find what is the force imparted by the ball on the hand of the player. See here, a player is catching a ball. Okay, he is taking 0.1 seconds in catching a ball of mass 150 grams. Okay, fine. So moving with a velocity 20 meter per second. Clear? See here. So let's suppose, so the ball is coming from here. So and the person is ready to catch the ball here. So the person is ready to, I am not a good, see here. So he is trying to catch the ball. Okay. So now see here, I can write, so the mass of the body is given, which is 150 grams. So convert it to kgs. So this one. Next, so the time taken is 0.1 second. Let it be. And then, so the ball's velocity, the ball is moving with a velocity 20 meter per second. So after reaching the hands of the person, so the ball's final velocity will become 0. Like once the person has catched the ball, so then the velocity of the ball will become 0, right? The final velocity is 0. So how much time is taking? So the t is equals to 0.1 seconds is taking. So they are asking force imparted. Simply, so the force will be equals to, shall I write, ma. So the thing is, here we know the mass, but we don't know the acceleration. So now what I am doing is, let's use the basic kinematics here. So the acceleration is equals to, we have got v minus u by t, the final minus initial by time taken. So then v is equals to, mass is 150 by 1000 into, so v minus u, final velocity 0, into initial velocity 20 by time taken. What's the time taken? 0.1 second. Alright. So then this becomes, I can write here, F is equals to 150 by 1000 into, so minus 20. So this is 1 by 10 I am writing. So in the denominator, so the 10 will move up. So minus 200. So here 2 zeros gets cancelled, and 2 ones are 2 5s are 5 ones are 5 3s are. So therefore the force is equals to minus 30 newtons. So let's consider simply the magnitude of the force, which is equals to 30 newtons. Clear? So the answer is option C. Understood, guys? Simple one, right? So, and one more thing, I forgot to write the dimensional formula. So the force dimensional formula you write down. So what are the dimensions of force? You have to remember that. So mass is m, and what is acceleration? L t to the power minus 2, right? So this everyone should remember. These are the dimensions of force. Already we discussed in the units and measurements. From now onwards, whenever the new term comes, you have to write the dimensional formula for that. Clear? Sure. Because we already studied the first chapter, units and measurements, right? Sure. Next. So let's take one more question, guys. A force of 15 newtons acts in the direction as shown in the figure. So the block of mass 5 kg resting on a smooth horizontal surface. Find out the acceleration of the block. So see here. So the first thing is the force is acting on this block in this direction. So whenever the force acts in this way, what you do is you just extend the force this way. You guys just extend the force this way. Okay. So now see here. So this force will have two components. So this total force is 15 newtons actually. So this force will have two components, the horizontal component of the force and vertical component of the force. So if it is 60 degrees, so this angle also will become 60 degrees. Yes or no? Now, so then this becomes 50 sine 60, and then this becomes 50 cos 60. 50 cos 60 degrees. Clear this part? This is 50 sine 60. This is 50 cos 60. So now what they are asking, see here, find out the acceleration of the block. So the body will accelerate due to the horizontal force acting on it. Yes or no? So on the body there are two forces are acting. One is horizontal force, one is the vertical component of force. So the horizontal, due to the horizontal component of force only, the body will accelerate. Yes or no? So that's why I am considering, so the x direction motion only. So I am considering the x direction forces only, because the x direction force is responsible for the acceleration in the body. Understanding? So now, so the body is accelerating right side, they clearly mentioned. So we know that the F net, the net force acting on the body, is equals to its mass into acceleration. So now I can write what is the net force acting on the body, which force is responsible for the acceleration. Acceleration is right side, so the right side force, which is 50 sine 60, is responsible for acceleration. So which is equals to mass of the body 5 into the acceleration we have to find. So therefore 50 into, so the sine 60, which is root 3 by 2, so which is equals to 5 into a. So 5 ones are 5 tens are, so here 2 ones are 2 5s are. So acceleration is equals to 5 root 3 meter per second square. So the acceleration is, so what they are asking, find out the acceleration of the block. So it is 5 root 3 meter per second square. So I guess options are given wrong. These options are not for this question, I guess. The next question's options are, because it should be meter per second square, so the options are misprinted, I guess. A force of 15 newtons acts on the body, yes, so at 60 degrees. So therefore 60 degrees, 50 cos 60 is equals to 50 sine 60. Okay, find these two. So 50 sine 60 is responsible for the acceleration. 50 sine 60 is equals to 5 into, so it's mass into the acceleration. Mass is 5 kg, acceleration is a. 5 into root 3 by 2. So this is 5 ones are 5 tens are, so 2 5s are, so 5 root 3. Yes, correct only. Yes. So don't consider these options, guys. So let me erase these. So don't take the options, these. Okay, done. Chalo. So don't take the options. So now, so for the same question, so the homework is here, write down the homework. So find out the normal reaction for this. Find out the normal reaction So consider this as a homework 1. So this is a homework 1. Clear? Understanding? Chalo. So next. So just ignore the options in this question. So I did not check. So that's a DTP mistake. Chalo. So next, let's move for the next one. So what's the next question says? Let us consider two forces F1 and F2 acting on a body of mass 2 kg. So this is a 2 kg body. So then, as shown in the figure, so F1 is 10 newtons, F2 is 2 newtons. See here, simply draw the free body diagram. Consider the 2 kg mass as the point mass. So the F1 force is acting this side, right side, right? See here, F1 force is right side. F1 force is 10 newtons, and then F2 force is left side, which is 2 newtons. Yes or no? F2 force is left side, 2 newtons. So what will be the acceleration? See, the body will accelerate obviously in the direction of net force. So the net force will be towards right, right? This side 10, this side 2. So obviously the net force. So I can write, so the simple formula, the F net is equals to M into A. So what is the net force here? So 10 minus 2 is the net force. Body's mass is 2 into the acceleration. So this is 8 is equals to 2 into A. So therefore acceleration is equals to 4 meter per second square. So pretty easy question, right? Chalo, next. So now, what is the motion of connected bodies? Let's consider. So there are three bodies, M1, M2, M3. So are connected, are in contact with each other. So now you are applying the force on one body. You are applying the force on just one body. So then this moves with the acceleration A. So they all move with the same acceleration. So first thing is they all move with the same acceleration. With what acceleration they move? So let's find it out. Okay. So what I am doing is here. So let's consider the free body diagram of each one. Let's consider the free body diagram of each one. So first, what are all the forces? See, the acceleration in the right side direction. So I just need the horizontal forces. No need to consider the normal. No need to consider the weight. So just ignore them because we just need the force is in the horizontal direction and acceleration is also in the horizontal direction. So now what I am doing is, so the forces here, there is a contact, so that the normal reaction exists. So here is again the contact force. So again, so the normal reaction exists. So vertical normal not required, but here this is important because this normal acts horizontally, right? So here shall I say that basics, that's it. I am not doing anything more here. So the M1 will exert normal reaction on M2 in this direction, and M2 will also exert same normal on the M1 in this direction. M1 will exert normal on the M2. So M2 also will exert same normal on the M1. Yes or no? So this point is clear now. So and one more thing. So here point of contact change. So the normal reaction changes. So the M2 will exert, let's suppose, normal N1 on the M3. So the M3 will also exert the same normal on the M2. Yes. So now draw the free body diagram of the M1 body. So just these are the forces I could see. Yes or no? So this is a block of mass M1. So I could see that on the block of mass M1, so the force is acting right side. Yes or no? See here, the force is acting right side, and on that the normal is acting left side, and the body's acceleration is towards right. So acceleration is towards right means this F is more than the N, right? So now write the equation for this. F minus N, let's write. So the F minus N, the net force is this one. F net is equals to mass of the body M1 into the acceleration of the body A. So this is for the first one. So now let's do for the M2 block. So for the M2 block, I could see that N is acting right side, the normal N is acting right side, and then N1 is acting left side. Yes or no? See here, N1 is acting left side, N is acting right side. So just these two are the forces, and body's acceleration is towards right. Body's acceleration is towards right. So that means N force is more than the N1 force. Yes or no? So I can write here that N minus N1 is equals to, so M2 into A, M2 into A. So now let's take the M3 block. So on the M3 block, I could see that only the force that is acting is N1. Only the force acting is N1. There are no other forces, right? Yes or no? So, sorry. So only the force that is acting is N1. Yes. So then I can write that the net force N1 is equals to, so M3 into A. M3 into A. So now let's add all these three equations. I could see that minus N plus N cancel, minus N1 plus N1 cancel. So here the F is equals to, let's add all these, M1A plus M2A plus M3A. So which I can write M1 plus M2 plus M3 into A. So from here, so what we are trying to find, what is the acceleration of the motion of connected bodies. So from here, so the acceleration is equals to, so the net force acting on the body by, so M1 plus M2 plus M3. So the simplest way to understand this is, so to find the net force, it is simply the F net acting on the body. So this is the only force, the net force acting on the body by, so what is M1 plus M2 plus M3? So the net mass of the connected bodies. So this is the net mass of the connected bodies. That's it. So therefore the A net is equals to F net by M net. The A net is equals to F net by M net. Just take the force and then divide by the connected bodies summation of masses. That's it. Understood? Clear everyone? So this is the motion of the connected bodies. So for example, see, so let's say if I give you, so the homework question, let's consider this as a homework 2. So consider here is a 5 kg block, and then here is a 3 kg block, and consider this is a 2 kg block, which are connected each other. So like this, and then so let's suppose the 10 newtons force is acting on the first block. So if I ask you to find the A net, so or A net, or I can say acceleration of each block, both are same, because each block will move with the same acceleration. If it is moving with the acceleration A, so this also move with the acceleration A, this also move with the acceleration A. Understanding? So that's a case. Done. Chal. So this is one point. So take this as a homework and comment down your answer. So next, let's move further. So let's consider this question, guys. So what's the question says here? 3 blocks A, B, C of mass. This is 4 kg. This is 2 kg. This is 1 kg. Fine. So are in contact on a frictionless surface. So there is no friction on the contact. So then if a force of 14 newtons is applied on the 4 kg block. So here 14 newtons force is applied. So then the contact force between A and B. So see, they are asking the contact force between A and B. Here what is the contact force? So that contact force is nothing but normal you have to find. In between these two blocks, what is the normal that you have to find? Okay. So first thing is, so first what is the acceleration of each block? Let's find. So the acceleration is equals to, we know that F net by the M net. So I could see here the net force acting on the block is 14 by M net. So the connected bodies 4 plus 2 plus 1. So which is 7. So 14 by 7, which is 2 meter per second square. It's the acceleration. The acceleration is 2 meter per second square. But what do we need? We need the contact force. So if A applies normal N on the B, and then B also exerts normal N on the A. So now consider the free body diagram of A block or B block, your wish. So I am considering the free body diagram of A block. On the A block, so I could see that the normal reaction is acting left side, right? And the 14 newtons is acting to the right. Yes or no? So normal reaction is acting left side. So the 14 newtons is acting right side. So the body is accelerating in which direction? So the body accelerates in the direction of net force. So that's why the acceleration is right side. So then apply the Newton's second law here. The net force, what is the net force? 14 minus the normal N is equals to, see, don't write N here. This is simply write 14. Again, you might confuse that. 14N minus N is 13N. Don't write that. So 14 minus N, this is the 14 newtons force minus this is the normal reaction N, which is equals to mass of the block 4 into its acceleration A. So now we have got what is the acceleration, right? So 4 into the acceleration is 2. So therefore, so 14 minus N is equals to 8. From here, the N is equals to 14 minus 8, which is 6 newtons. So the normal reaction is 6 newtons. Option B is the correct answer. Clear, guys? Understood, everyone? Sure. So let's move further. So now again the motion of the connected bodies. Previously they are connected by they are just connected so by touching each other in the last case. So here they are connected by the strings. Okay, so let's derive the formula in this case. Again the same thing. So this is of the mass m1. So here let's suppose the tension T. Whenever there is a rope, there will be the tension force comes, right? So here tension T. So as this rope is same, the tension is going to be same here. So see here the tension changes because the mass came in between. So here the tension T1 because, sorry guys. So this total tension here T1, here T1. So here it is T. So then the force F is acting to the right. So now draw the free body diagram of each block. So if I consider M1 block, so there is only force that is acting is the tension force. So this will accelerate right side, this will accelerate right side, this will accelerate right side with the same acceleration. So then what is here force? The net force. So the T is equals to, I can write M1 minus M1A. Yes or no? The body accelerate to the right. So the only force acting on it is net force is T, the tension force, and net force is equals to mass into acceleration. Mass is M1, its acceleration is A. So then, so draw for the M2 block. For the M2 block, I could see T1 force is right side and T force is left side. So and body's net acceleration is towards right. So that's why T1 minus T is equals to M2A. T1 minus T is equals to M2A. So similarly, draw for the third block. So for the third block, I could see that T1 is acting left side. So then right side, the net force F is acting. So the acceleration is towards right. So that's why I'm writing F minus T1 is equals to mass of the block M3 and it's moving with an acceleration A. So here simply you can cancel out T, just add these three equations. So and then T1 gets cancelled. So the F is equals to, I can write M1A plus M2A plus M3A, which is nothing but again M1 plus M2 plus M3 times A. So the same thing. So here the acceleration is equals to, I can write, so the net force by M1 plus M2 plus M3. So simply I could say that, so the A is equals to F by the net mass. So yes or no? So whether the masses are connected one to one, just there is a contact force, or whether they are connected by the strings. So to find the net force, so to find the net acceleration, the simple concept that you can apply is, so the acceleration is equals to net force by net mass. Net force by net mass. That's it. So F by M net. Clear? Understood, guys? Chalo. So this is a concept. So now let's move for the next question. See, find the acceleration of both blocks and tension in the string. So first of all, this is considered as the Atwood mission. This is the Atwood mission. Okay. So the standard result of this you should remember. So here, if you observe, first I am consider the mass M2 is greater than M1. Mass M2 is greater than M1. So now see here. So obviously, what are the forces that are going to act here? Here away from the block tension T, because there is a string. So here downside M2G will act, right? So then here M1G will act, and then here the tension T, because the string is same throughout, there is no mass in between, and in our syllabus whatever the pulley is given, so that pulley is considered as a massless and frictionless. So that's why you need not to consider this pulley as a separate mass. If there is no mass in between, the tension in the rope remains constant, remains same, right? So this point is clear. Understood? Now, so the thing is here, I considered the mass M2 is greater than M1. Obviously here this block accelerate downwards because the M2 is greater and M1 is lesser. Obviously this side it slides. Yes or no? This side it slides and its acceleration will be upside. So with whatever the acceleration it comes down, so with the same acceleration it goes up. So with whatever the acceleration it comes down, so with the same acceleration it goes up. Yes or no? So now see here, m2 is greater than m1. Just draw the free body diagrams of each one. If you draw the free body diagram of m2 block, consider the m2 block. So I could see that tension force is acting upside, and then the m2g is acting downside. And where is the acceleration? The acceleration is downside. The acceleration is downside. So I could write the equation here that m2g net force is downside. That's why the acceleration is downside. So m2g minus t is equals to its mass m2 into the acceleration a. And similarly consider the block of mass m1. So for the m1 block, the tension is acting upward and its weight m1g is acting downward, and its acceleration is upward. Yes or no? Its acceleration is upward. So that means the net force is upwards. So I can write for the second block, so which is t minus, so t is a more force, that's why acceleration is that side. So t minus m1g is equals to its mass m1 into the acceleration a. So therefore I can write here, so the tension cancel. So here if you add these two equations, I can write m1 plus m2 into g is equals to, so m1 plus m2 into a. So if you add these, m2g minus t is equals to m2a. So here m1 plus m2 into g, so is equals to, yes or no, minus, right? See here, this is going to be the m2g minus m1g is equals to, so just add these two, so which is going to be m1 plus m2 into a. Yes or no? This is m2g here minus m1g. So m2g minus m1g is equals to m1 plus m2 into a. So from here you can write the equation of the acceleration. The acceleration is equals to, so shall I write m2g minus m1g by, so the net mass. So again the same concept, see here, whether it is a pulley or the masses are connected one to each other or they are connected by the string. So the simple equation that you can apply is, so the F net by m net. The acceleration is simply the F net by m net. What is the net force here? The force acting on this block is m2g. The force acting on this block is m1g. So the net force is, obviously the acceleration is downwards. The net force is m2g minus m1g. You can write m2g minus m1g by, so the summation of masses. What are the masses? m1 plus m2. Simply m1 plus m2. That's it. Understood, guys? Clear this part? This is the acceleration. And for this Atwood mission questions, so the tension will be given by, so 2 m1 m2 by m1 plus m2 into g. So this is the formula to find the tension. So where you can, if you want, you can substitute the acceleration and get the equation for t. If you substitute acceleration equation any of these and write the equation for t, so you are going to get that. So t is equals to 2 m1 m2 by m1 plus m2 into g. So you have to remember this as well. Understood? Clear, everyone? Is the concept clear or not? Chalo. So let's move further. Chalo. So let's move a bit faster. So see here, what's the question says? Two masses m1 and m2 are connected at the ends of the inextensible string passing over a frictionless pulley. So they two are connected. So this is a pulley. So this side. Consider, so this is a 10 kg block m2, and then this is the 5 kg block m1, let it be. So they are connected like this. When the masses are released, so then find the acceleration of the masses. Simply the acceleration they are asking. What's the acceleration? So simply F net by m net. So what is F net? So which is, this is m2. Consider this as m2. Consider this as m1. So here the force that acts is 10g. And here the force that acts is 5g. So what is the net force now? So the 10g minus 5g is the net force by, what is the net mass? So 10 plus 5, 15. So which is equals to 5g by 15. Yes or no? So then 5 into 3. So which the acceleration is going to be g by 3. So the acceleration is g by 3. So option C is the correct one. So if see the both blocks has the acceleration g by 3. So if they specifically ask what is the acceleration of M2 block, it is a g by 3 downwards. It accelerates downward. If they specifically ask what is the M1 blocks, so it accelerates upward with g by 3. G by 3 here upwards, here g by 3 downwards. Clear? Understood the concept? Chalo. So let's move further. So let's take the next question. A mass of lift is 200 kg when the tension in the supporting cable is 28,000 newtons. So then its acceleration. See, so the lift kind of questions. So let's consider this is the lift. Okay. So the lift weight, consider the lift mass is m. So the lift weight will be mg. Okay. And the lift is connected by the supporting cables, right? So the supporting cables will have the tension T away from the lift. Yes or no? So you can write simply. So the here, let's suppose if the lift is accelerating upward, so you can write the equation. So the tension will be more. T minus mg is equals to, so it's mass into acceleration. Okay, if the lift is accelerating upward. So otherwise, if the lift is accelerating downward, if it's coming down, so then you can say that mg is greater. So then you can say in the second case, so mg minus t is equals to ma. So this is the concept you should apply for the lift questions. Okay, if the lift is accelerating up means the tension is more than the mg. So that's why net force will be T minus mg, which is equal to its mass into acceleration, Newton's second law. And then if the lift is accelerating down, so that means the net force is more towards the down. Mg minus T is equals to ma. So what they are saying in this given question, this is a concept of lift questions. So now see this question. A mass of the lift is 200 kg. Consider this is a lift which is of mass 200 kg. Fine. So when the tension in the supporting cable is 28,000, so supporting cable will be obviously this side. So this is going to be, the tension is 28,000 newtons. So now, so if you observe what is the mass, the mass is 200 g. Weight, sorry, so 200 into 10, so let's consider g as 10. So this is going to be 20,000 newtons. So this is 20,000 is a mass this side, and then tension is up 28,000. Obviously the tension is more than the weight, so that's why the acceleration of the lift will be upwards. Yes or no? So then I can write the equation that T minus mg is equals to ma. The tension is more, that's why T minus mg is equals to its mass into the acceleration. So simply you can use tension is 28,000. So minus mg, which is 20,000, mass 200 into the acceleration. So from here this is going to be 8,000. So which is equals to 200 into a. So from here 2 zeros cancel. So the acceleration is equals to, so what is this? So this is 8,000 only, right? So 8,000 is equals to, so sorry, this should be 2,000 guys. The question given wrong. So consider this as 2,000 kg. Yes or no? So this is 2,000. 200 into 10 means 2,000 only. So but 2,000 g here it is. So in the question it should be 2,000 kg. So then only we'll get the correct answer, I guess. Yeah. So because if it is 200 kg, so you should get 40, but 40 is not there everywhere. So only 4 is there. So that means this is 2000. Yes. Chalo. So now, so this is 2000 means here 0 will come. So 80 by 20. So the A is equals to, here it is 2000. Okay. A is equals to, so 80 by 20, which is 4 meter per second square. So this acceleration 4 meter per second square in which direction? So this acceleration A is equals to 4 meter per second square upward. So this is upward because the tension is more, right? So that's why it's a 4 meter per second square upward. Option B is the correct one. Clear? Next. Let's go for the next question. So what's the question says? A lift of mass 1000 kg is moving upward. Again the lift question. So do it fast. So this is the 1000 kg. So which is moving upwards with an acceleration of, so this is a supporting cable and this is a weight. So weight is 1000 G and the acceleration that they gave it as 1 meter per second square upwards they gave clearly. See here. So the tension developed in the string which is connected to the lift G, strictly take it as 9.8. If they mention it in the question, just take that value only. Okay. So now see here. So obviously the tension is this way. So if the lift is moving upward means, so the tension is more than the 1000 G. So T minus 1000 G is equals to, so I can say it's mass 1000 into the acceleration A. So now substitute the values. T minus 1000 into 9.8, G is 9.8, which is equals to 1000 into the acceleration A. So from here T minus, so this is going to be 9800, which is equals to 1000 into the acceleration A. What is the acceleration that they gave in the question? 1. So from here T is equals to, so I can say 1000 plus 9800, so which is nothing but 10,800. So the tension is equals to 10,800. So don't consider G as 10. See here, if you consider G as 10, so this will become 10,000. So 10,000 plus 1000, which is 11,000. So the option 11,000 is also there here. But in the question they strictly asked you to take G as 9.8. If they don't mention, you can consider it as 10. Okay. Chalo. So let's move for the next question. So the question 9. So what's the question says here? A person of mass 60 kg inside a lift of mass 940 kg. See here, this is a lift. So and there is a person whose weight is 60 kg and the lift weight is 940 kg. Fine. So overall weight is again 1000 kg. Okay. So and pressure on the button on control panel, the lift starts moving upward. So moving upward with an acceleration 1 meter per second square, right? So then if G is 10 meter per second square, they mentioned 10 here. The tension in the supporting cable, same question. So here the tension T. So here the what is the weight? 940 plus 60,000. G is a supporting weight. So total weight. So as it is moving upward, the tension will be more than the weight. So I can simply write T minus 1000 G is equals to mass, which is 1000 into the acceleration. Here T minus, so consider G as 10. So this becomes 10,000, which is equals to 1000 into the acceleration A 1. So T is equals to 10,000 plus 1000. So here it is going to be 11,000 newtons. So here it is going to be 11,000 newtons. Option B is the correct one. Clear, everyone? Chalo, next. So next question. See the next question, guys. What's the question says? A monkey of mass 20 kg is holding a vertical rope. The rope will not break when the mass of 25 kg is suspended from it. But if the mass exceeds 25 kg, so it breaks. So if the mass exceeds 25 kg, but will break it here, but will break if the mass exceeds 25 kg. So what is the maximum acceleration with which the monkey can climb up along the rope? So they are asking what is the A max. Find A max. That's the question. Just try to understand the concept first. See here. So here is the rope. Here is the rope. So a monkey. So consider here is a monkey. So this monkey is trying to climb up the rope. Okay. So the monkey's mass is 20 kg. So obviously its weight is going to be 20 G. Its mass is going to, weight is going to be 20 G. So if it is climbing up, so the tension will develop here, away from the point of contact, away from the point of contact in the rope. See here, rope. So the tension will develop. So then, so it's climbing up. So that means its acceleration is upward. Yes or no? So then shall I write the equation that, so the T minus the tension minus its weight 20 G, T minus 20 G is equals to its mass 20 into the acceleration A, into the acceleration A. So from here the acceleration is equals to T minus 20 G by 20. So the T minus 20 G minus 20. So here they said what is the maximum acceleration. If the acceleration has to be maximum, So then the tension in the string will be maximum. If they are asking what is the maximum acceleration, if the acceleration whenever it becomes maximum, so the tension also will become maximum. Yes or no? So the tension, if the acceleration maximum you have to find, simply write the tension maximum. So the tension maximum, what is the tension maximum? What's the hint given in the question? Observe carefully. So the string will break if the mass exceeds 25 kg. Up to 25 kg, the rope can withstand the monkey's acceleration. But if it exceeds 25 kg, if the mass exceeds 25 kg, it will break. So that means the maximum tension, the T max will be equals to the maximum weight. What is the maximum weight that it can bear? So 25 kg. So that's why the T max is equals to 25 G. So in place of T max, you substitute 25 G. The simple question, the simple logic, first you wrote the equation for this, and then you have to find the acceleration maximum. Whenever the acceleration will be maximum, when the tension is maximum. That's it. So 25G minus 20G by, so just take 20. So the A max will be equals to here. So this is going to be 5G by 20. So the A max is equals to, this is going to be 50 by 20, which is nothing but, so 2.5 I guess. Yes. So 50 by 20. Yes. So fine. So this is 2.5 meter per second square. So this is the maximum acceleration with which the monkey can climb up the rope. Clear? Understood the concept? So next question. See the next question, guys. So what's the question says here? See this question. So the strings are inextensible and light. The pulleys are smooth and light. So find the acceleration of each block and tensions in the string. So there are 3 blocks I could see, and we have to find the tension in the each block and acceleration of each block. So simple question, you can easily do. See here. So consider, let's suppose I am considering the tension T here. So then the weight 3G downside. So here tension T. So there is no mass in between. So this is going to be like this. The pulleys are inextensible and massless and frictionless. So here if it is the tension T, here also the tension T. So here 2 kg mass came in between, obviously the tension changes. Here if it is T1, so here it is going to be T1. Yes or no? So here it is going to be 5G. So first what I will do is, I will find the net acceleration. I will find the net acceleration. We know that the A net is equals to F net by M net. A net is equals to F net by M net. What is F net? Net force acting on the body. So that is 5G minus 3G. This is more, this is less. So for the pulley type questions, M2G minus M1G we did, right? So similar way, 5G minus 3G. So by the net mass, what are the net mass? 5 plus 3 plus 2. 5 plus 3 plus 2. So this is going to be, so 2G by 10. So G 10 cancel. So the acceleration is going to be 2 meter per second square. So the acceleration is going to be 2 meter per second square, right? So now, so this accelerates downward, right? So because this mass is more, this accelerates upward, and then this accelerates left side, right? So simply you can use the, for the 3 kg block, if you draw the free body diagram for the 3 kg block, so the tension is upward, the acceleration is upward, and then its mass 3G is downward, right? So I can simply write for this T minus 3G is equals to its mass T into the acceleration A. Its mass 3 into acceleration A. So from here, T minus 30 is equals to 3 into the acceleration, which is 6. 3 into 2 is the acceleration, 6. So from here, T is equals to 36 newtons. This is done, the first one. We got the tension T, right? So similarly, can you find what is tension T1? Can you find what is tension T1? So for that, I am taking the block of mass 5 kg. For the 5 kg block, so the tension T1 is upside, the 5G is downside, and then the acceleration A is downside. So I can see here that the 5G minus T1, 5G is more, that's why acceleration is more, which is equals to, what is the mass of this 5 kg block? So mass is 5, into its acceleration is a. So I'm not doing anything new. Just first I calculated the net acceleration, then I am drawing the free body diagram of this and this. That's it. Okay, chalo. So 5g minus t1. What is the 5g? What is the 5g? 50 minus t1 is equals to, this is 5 into 2, 10, right? So acceleration is 2 kada. So then, so t is equal, so I can write t1 is equals to 40 newtons. So that's it. We have these things only. The acceleration of each block is first 2 meter per second square. That point is clear. And then the tension in this string is 40 newtons, and the tension in this string is 36 newtons. That's it. Done. Chala. So let's move for the next question. See here. So what's this question says? In the arrangement shown, all surfaces are smooth, strings and pulleys are light. All surfaces are smooth and strings and pulleys are light. Find the tension in the string. We have to find the tension in the string. So the first thing is here. So the basic understanding. So this side, if it is a 2 kg, so shall I say that 2g sine 37 will come this side? Already we have seen in the last classes, right? So if the body is on the inclined plane, so along the incline, its sine component will come. So the 2g will act vertically downwards. So 2g sine 37 will come this side because this angle is 37. And obviously this side, it's going to be 2g sine 53. This side, it's going to be 2g sine 53. This understanding you required, guys. Okay. So now you know the triangle 37, 53 and 90 triangle, you know. So this is 3, this is 4, this is 5. So simply, so this force will become, so what is this force will become? 2 into g is 10 into what is sine 37? Sine 37 is 3 by 5. So this is going to be 5 ones are 5 twos are. So 2 to 4, this is 12 newtons. And this force is 12 newtons which is acting this side. This is 12 newtons which is acting downside. And what about this? So this is 2 into g is 10. What is sine 53? 53 means 4 by 5. So obviously this is going to be 5 ones are 5 twos are 4 into 4, 16 newtons. So that means this side force that is acting is 16 newtons. Again consider the same thing. Find the A net. What is the A net? 16 newtons force is acting this side. 12 newtons is acting this side. Which side the net force is there? Obviously this side, because this pulley is the frictionless and massless, right? So the net acceleration is 16 minus 12 by the net mass. What is the net mass? 2 plus 2, right? So the simple thing, so this is 4 by 4. So the acceleration is 1 meter per second square. 1 meter per second square. What we have to find? The tension T. So here if the tension T is there, so here also the tension T. Draw the any block's free body diagram. So if I take the 2 kg block this side, so see here, if I consider the 2 kg block's free body diagram, so this 2 kg block I am considering. So this side 16 newtons is acting, yes or no? And this side the tension is acting 16 newtons and tension, and then acceleration is along the 16 newton side. The acceleration, yes or no? This force is more, that's why it accelerates right side, it accelerates upside, yes or no? So then simply apply the Newton's second law here. So the net force, what is the net force? 16 minus t is equals to mass 2 into its acceleration a. So therefore 16 minus t is equals to 2 into acceleration is 1. So from here t is equals to 16 minus 2, which is 14 newtons. So the tension in the string is 14 newtons. That's what they asked. Find the tension in the string. That's it. So which is 14 newtons. That's it. Understood the concept? Chal. So the same question. So no need of another slide. So here find the tension T1 by tension T2. So take this question as homework 3 or 4, I guess 3. So take this question as homework, guys. Take this one question as homework. So you just try to solve it on your own. Here tension is T2, here tension is T1. You just have to find what is the tension T1 by tension T2. Can you guys solve this question? Same, previously I already solved 2 questions, right? This one I solved, this one I solved. So which are very easy, right? So chalo guys, I'm going to wind up this lecture here. So in the next lecture we are going to discuss, so what is the relation between So the change in momentum and impulse. Okay, and we'll also solve the graphs related to that. How do we solve the graph questions? So that also we'll do in the next session. So till then, keep studying. All the very best. Bye guys.